middle team, Pythagoras, etc. Inductive or deductive? Yes, defend yourself. Why? Yeah, he takes an observation and then he discovers an aha. Okay, this one. First off, front right team. What are the next three numbers? 34, 55. Middle front team. What's the pattern? Yes, you sum previous two numbers to get the third number. All right, I'll take a volunteer with this one. Remember that in November, we're going to cycle back to it. Ready? Now I'm just going to do a quick survey. How many of you thought this was inductive? Inductive. One lone holdout. Remember this moment, guys. Okay. How many of you think it's deductive? Okay. Raghav, always stick to your guns because, ladies and gentlemen, it is both. It is both. Right? Let me show you why. Because making observations and doing that pattern. That's an observation to discover truth. So discovering the pattern is inductive. Using the pattern, deductive. I know, I was messing with you. Sometimes you got to think outside the box. Okay, ready? Every what is okay, rotate forward. Rotate forward. Okay, lights again, please. I think that'll help for you to focus here. Whoops, I thought there it is. Okay. Yes, lights, please. Thank you. Appreciate that. Back to your reference booklet. That was cycle number 1. Cycle number 1 is going to logic that. Guarantee you know all of these. We just have fancy names for things that you know instinctually. So the first one's called law of detachment. Ready? I'm just going to give you the symbols and then I'll give you an example. If P then Q is 3, because just circle the whole thing and write 3. Back to your reference booklet. We're going to go back and forth 3 times, guys. Help each other. You're lost right now. Poke a neighbor in the shoulder and ask them, where are we? Okay. If P then Q is true, if P alone is true, then Q alone is true. P alone is true. Q alone is true. So law of detachment. I'll give you an example in about 10 seconds. This won't make sense until it will be example. Here's an example. You wear jeans. General observation. No one is 18. That's P alone is true. Therefore, no one wears jeans. That's Q alone is true. That's attachment. You can detach the P and the Q stick. That's going from generalization to specific. It's basically deductive reasoning. Contrapositive. We did this last, and you did this last night with the whole apple fruit apple thing and Mustang car Mustang thing. If P and Q is true, then only the contrapositive must be true. Must be. So like me, say they're false. We've done that. I eat a How does that read to your neighbor and tell them what it's true or false? This one, if the contrapause would read, if I don't, you know what? Okay, so that is an example of what's called contrapositive. Contrapositive. Syllogism. You guys know syllogisms all the time. You know this. So if you hear something like this, if you're grounded, you don't get to go to the party this weekend. Well, you don't go to the party this weekend. See, I told you guys. It's called a syllogism. That's called a syllogism. If P and Q is true, and Q and R is true, then P, Q, R is true. Called a syllogism. Next time your parents give you one of those, you can kind of like stop the argument and say, wow, that was a syllogism. And see the expression they get on their face. Might be kind of fun. Okay, conjunction is an and statement. Disjunction is an or statement. Next symbols for these. An and statement, we use like a caret. Or statement, we use a V thing. Just write this down. I'll give you an example. Really easy. Okay, ready? Okay. Let's see what happens. I say this statement. I am a teacher and I work at Yahoo. I am a teacher and I'm a quarterback for the 49ers. True or false, guys? No, not a false. It's false because I use and. Now, what if I say this? I am a teacher or I'm a quarterback for the 49ers. Just check. I live in San Jose. What's that? Scratch that. I live in Texas or disjunction is only false when both are false. So an or statement is only false when both are false. An and statement is only true when both are true. Pretty common sense. Pretty common sense. No, I don't. Awesome. Okay, now go to, in today's lesson, go to example 2 on page 3. In today's lesson, example 2. Make sure it says example 2. You good? Look up here, guys. Make sure you're on the right one. Star player, timeout. You got it? Okay. So now we're going to use these logic laws to determine what could be true. We are given that both these statements, so just label them statement 1, statement 2. Both statements are true. If a star player is on the bench, a timeout has been called. Timeout has been called Q. That's statement 2. If the timeout has been called, that's going to be Q. Again, no. Then fans get restless. That's going to be our third statement. We're going to use these logic laws to determine what could be true. These 3 logic laws. Ready? Okay, so the logic law is this. Syllogism says the P, then Q is true. And Q, then R is true. P, then what? R. So we know if P, then R has to be a true statement. Okay? Holler at me if I need you. We also know contrapositive. So let's do the contrapositive of statement 1. Switch and negate. Remember that little Spanish tilde sign when you say the opposite. That's the contra of first. Ready? Let's do the contra of the second statement. So you switch and negate. Logic was these 3 statements must be true. Everything else is going to be false. So what I'd like you to do is we're just going to do the letters first. Let me show you what I mean here. So right here, star player sitting on the bench. That's going to be just P alone. Just do letters. Don't do the little true, false, and Y yet. Ready? Star player sitting on the bench. That's P. Fans get restless. That's R. Do you see what I'm doing? Translate the phrases into the letters. It makes it easier when you do that. 3. Fans do not get restless. That's opposite R. Timeout not called. That's opposite Q. Do you see what's going on there? Okay. I want you just to do the letters. Just the letters. Nothing else. Just the letters. 4 and 5. So just the letters. How to do the letters. Just the letters. Right now. Do anything else. Just the letters. Q, R, opposite P, opposite Q. Stop that pattern. Remember, it's all about paying attention. Just a letter. Okay? Okay, let's see if you got these letters. Timeout has not been called. That's going to be opposite Q. Opposite Q. Then star player not on bench. That's opposite P. Last one, timeout not been called. That's opposite Q. And fans do not get restless. That's opposite R. Sounds like we can at least do the letters. Okay. Got it? All right. There's 2. Now we do truth value. Number 1, P alone is true. You're not told P alone is true. Okay, so if something's not for sure true, you call it false. 5, P alone, not given true. I'm going to do 2 more with you. Star player on the bench, fans get restless. If P, then R. Look at our chart here. One of our yes. So we write true. The reason why is that was the syllogism. Of syllogism. I'll do 3, 4, and 5. You're going to do on your own. Fans do not get restless. Timeout not called. Opposite R, opposite Q. Look what that is. Look. See the math? This is all about paying attention. That one's true because it is the contrapositive of the second statement. See what's going on there? I want you to do 4 and 5 on your own, my friends. I'm going to freeze this. You do 4 and 5. All right, guys, ready? Check. Check. What I want you to do is associate it just with phraseology. That and just really, literally interpret. Okay? Don't read too much into these statements. Okay. Well, that's the problem. I was trying. I'm gonna get tired. All right. To the scale of 1 level here, guys. 1 to 5. All right. Most of you are like 3/4 of the way. Not bad. Everybody. Last page. There, just flip it all the way to the back. All the way to the back, page 8. Okay, you're looking at this page. Ready? Can someone turn on the lights, please? Lights, please. Thanks. And honestly, you know these. I'm just giving you fancy name for stuff you already know. Okay, very common. When we distribute, I want to see two. One, never distribute just with your eyeballs. I want you to grab what you're going to distribute. That means split. And I'd like you to draw the little distributive area. Like it goes with the play chart working ahead. Okay, so we have 2x plus 6 equals 10. Please respect the fact that I've had nearly 2,000 students through this classroom. When I ask you to do tiny little stuff like that, there's a reason why. Okay, we are back on the reference booklet. 5x minus 2x, and then we do this. Notice I am basically subtracted on one side. When we subtract or add on one side of the equal sign, that's called addition or subtraction of real numbers. You guys know it as select, like. I want you to use addition, subtraction. Not to be confused with this. See what I did there? This one. Am I on one side or two sides? Two sides. So we call this addition property. When we work both sides of the equal sign, addition, subtraction, multiplication, division, it's called property. We're halfway there. So here, if I want to solve, I multiply by the reciprocal, both sides. And that's multiplication property again. If I divide it into okay. This one, if you have a proportion, you can cross multiply. Cross multiply. When you cross multiply one, you will always actually physically draw the cross multiplication. 2, you never ever distribute in your head. Let me shrink this back so you can see it. So see here, your next line is not going to read 9x plus 27. I went 9 to prevent x. Do not combine those. Cross multiply. Cross multiplication property. Okay, ready? Okay, so here we have x squared equals 64. I'm going to do the don't do this sign first. Ready? Look. See that little don't do this sign? Yeah. So put this in there. I want you to look at that for 10 seconds. Okay. Alrighty, guys. So the opposite squaring is not divide by 2. The opposite squaring is square rooting. Okay, so we have x equals 8, not x equals 3. Okay. All right. Here I have 3 times x equals unknown. X equals 8, so I can do this. That's called substitution. Really hard. That's my okay. Leave that right in front of you. Now go to the lesson and find example 3. It's on page 4. Found it? Page 4, example 3. We're doing this right now together. Yes. So you guys are completely fine with the answers. You're going to do how you have and the on the right. Okay. So just as if you're solving, let's go ahead and start. We grab that 4. Distribute. We grab that -5. Notice I only did one step, but we did. The permission to go from here to here was the distributive property. So that was the why this is allowed. Why is this logical? Now I'm going to inside table. Notice I like to circle times to keep my brain straight. I kind of recommend well. And because we were technically working on one side of the equal sign, it's fine, not crossing, all that is both sides. Okay, so this would be subtraction property. Now, some of you, your first instinct would be to go the other way. That's fine. Do this. Okay, last little step here. See what's going on here? Okay, scale 1 to 5. 1 being easy, 12 down 5. How hard was that to you? Or 1 you put. Okay. Great, grand. Do the next one on your own. Go. Next one. I'll show you the answer momentarily. Take a stab at that completely on your lonesome. Okay, if you're combining set, one step at a time. if you're done, find that one page you haven't fixed yet and that. I'm going to show you the answer in about 1 minute here. Thank you. Hey guys, grab your again. If you're in between steps, I just want to